This is a presentation on handling graphs in Excel and statistics with InStat, which you may find useful when you are doing your final research project report. What I have here is some some hunter data. Okay, this was from muffins. This measured the hunter values of the bottom of the muffins. I have a control group, and these are those values. There were 6 muffins in each group. This one has some of the fat replaced with the galacto-oligosaccharide. Here are its LAB values. And then similarly, this group had some of the fat replaced with fibrosol, and here are its LAB values. Now you see that I've entered the 6 muffin values, then I calculated the average here, and then I calculated the standard deviation. So I need to aggregate these in order to make a graph so you can see what is compared to what. I need to make a graph of this, and so to do this, I need to aggregate this line, and this line into one table, which I've done down here. Okay, so now I can just copy, I can highlight this table, and then I can go to Insert, and I want a column, and I want a 2D column, I believe. There we go. So we'll just set this down here. All right, and we'll move this a little, we'll resize it some so we can get rid of these internal lines. And now what we want to do is we want to enter the error bars. Okay, these are the L, A, and B errors for the first column is for the control, the second column is for the GOS, and the third column is for the fibrosol. So let's do the control first. So we'll click on the control, then we pair to the layout tab, and then on to error bars. More error bar options, and then I want to move this over here where it's sort of out of the way, and I want to click on custom. I want to specify the value. The reason I want to do that is because I know the values. I've calculated them. So I'm going to click specify value, and here I'm going to put 3.72, comma, 1.3, comma, 2.54. And these are the positive error values, so I need to copy and paste those into the negative error value box. And then if everything worked out right, these will show up here just as such. Actually, I don't think that is correct. Let me specify the values again. There's the problem. See, I put in 1372 instead of 1372. And I thought that error bar looked a little big. Let's see if it gets smaller. Yes, indeed, it does. It gets a lot smaller. So that's for the control. Let's do the reduced fat with GOS as well. So we click on the sort of orangey looking bar. Those bars are all highlighted. And what we can do, let's close this. We need to go back to error bars, more error bar options, custom, specify value. And again here, I need to highlight the one now so it'll disappear when I put these other ones in. There we go. So now I'm going to use this bunch here. This is the GOS standard deviations. So 2.22, comma, 2.22 again, comma, and 2.33. Now again, those are the positive values. I will highlight them, copy them, and paste them in here, and then we'll go OK. So now you see the error bars on the reduced fat plus the galacto-oligosaccharide. We can do the last one. We'll highlight the fibrosol, and again, same thing, error bars, more error bar options, custom, specify value. Go in here carefully and highlight that. So now it's 1.87, comma, 0.63, comma, and 1.47. And again, those are the positive values. I highlight and copy them and paste them in here. And we see the all the error bars for this. Now this thing is still incomplete because we don't have a table uh, title, or we don't have the axes labeled, so we need to go do that. So still on the layout bar, we're going to look at chart title, centered overlay, and we've got it here now, so we'll just go in here and we'll start typing Hunter parameters for fat reduced muffins. Okay, and I can even save myself a little work if I put figure 1 in here. All right, so then I'll click the little check mark and that should show up, and it does. Now again, remember, for Journal of Food Science style, I need to have this title below the graph, so I will move it down here, and I will move this up a little bit. There we go. So now that is looking a little better. I've got the title where I want it. Now I've got to label the axes. So I want to click on this. I want to look at the axis titles. We're going to look at the horizontal first, title below the axis. We're going to call this Hunter parameter. And we'll click yes right there, and that's fine. And then we still need to do the vertical one, so we'll go to axis titles, vertical axis title rotated, and we're going to call this one Hunter parameter values. Okay, and we'll click the little check box there, and that should give us Hunter parameter values right here. Now, so that looks pretty good. Maybe we can move this over just a little bit so it doesn't quite overlap too badly. There we go. Now that's not bad. So that's reasonably good for a bar graph from the data that we had. But we still don't know which of these means, these are all L values for the various variations. Are these different or not? Are they statistically significantly different? That's what we don't know. So here's what we have to do. We will go and take this data, this data up here, for the L's, for the control, we'll take this column of L values, this column of L values, this column of L values. We'll put them all in one table, which is here. Here's the L value for the control. That's what LC stands for. LGOS, which is the L values for the galacto-oligosaccharide variation, and LF2 for the ones with fibrosol 2 in them. Now, in order to do the statistics on this, what we can do, and let me go back here and make sure where I'm at. Here's what our data will eventually look like with no statistics. Okay, so we're going to put the Hunter L values through our InStat program. So now I need to go back to those L values. I'm going to copy them. I'm going to highlight them. I'm going to copy them. Then I'm going to open InStat. I want to compare means. I'm going to use the raw data. I had more than 2 groups, so I'm going to do one-way analysis of variance. So now I go down here to the bottom. I click the blue arrow. Now, remember I cut and pasted, or I highlighted all the stuff in the Excel sheet, the L values. They should come in right here. There we go. I just went Control V, and that pasted everything in. So now I can click this, and there's really not much to look at here. But when I get here, one more right click, I want to do all the columns. I want to perform ordinary analysis of variance. I want to use standard parametric methods. And if there's a difference, if there's a statistical difference, I want to use the Tukey comparison. There are other ones, and if you have good reason to know that you should use one of these other ones, that's fine. But Tukey is the one that comes up as the default, and that's fine. And so what it says based on my answers here, it says we will do one-way analysis of variance with a post-test. So now I click the little arrow, and here's what I get. And it says they're considered extremely significant. Okay, in fact, what it says is, here's my little asterisks, and all the p-values are less than 0.05. They're all different from each other. They're all, the control is different from the GOS, is different from the F2, so forth and so on. So they're all different. All right. Now let me go back here. So here's the values we were just talking about, those L values, and we've run them through the InStat program, and the InStat program says the L values are all different. So I don't have to do anything fancy here. I can just put the A, B, and C to indicate that they are different. And you'll see later I put a little note below the table that means and within columns not bearing the same letter are statistically significantly different. So now I want to put the A values. So I've got my A, B's, and C's in here, and I want to put the A values through. So I go back to my data, and I have the A values here. Similarly, I just clicked on the A tab, the A worksheet, which I collected all that A data. Now let me go back to the InStat program. We can go all the way back to the first one, and what we have to do is get rid of this old data. All right, let's just highlight this stuff. Then we'll click in here and delete. All right, now we're good to go. Now I want to go back to the Excel. I've got that highlighted. These are the A values. I'm going to copy that. And now I'm going to go here and I'm going to paste this. And there's my A values for the different muffins. Okay, same drill here. Click, nothing much to see here. Click again. Here's where I set everything up. I want to do all the columns. I want to perform analysis of variance. I want to use standard parametric methods. I want to use the Tukey comparison test. This will do one-way analysis of variance for me. So what this says here, now my value is 0.11, my p-value is 0.1102. This is considered not significant. So none of the A values are significantly different. Okay, so when I go back to my table, I have put the 100 A values through InStat, and the InStat says no A values are different. So I don't have to do anything here. I don't have to put any little lowercase letters because they're all different. So I mean, it says no, and none of them are different. So I don't have to make any distinguishing. Use those distinguishing letters like A, B, and C, and so forth. So now I want to finally put the B values through InStat, and that would be these over here. So now I'll go back to my Excel sheet. I click on the B worksheet where I've gathered all of that data together. You see it's highlighted here already. We go back to InStat, and we'll go back here, and we'll get rid of the old data. Okay, now we go back to here, Control C, back to here, Control V, and there's all my data just pasted in. Okay, so again, right click the blue arrow, nothing much to see here. Here's where I set everything up. It's not changed from what it was before, so we just leave it that way, and now we click on this, and sure enough, this is considered significant. What this says is that the B value for the control is different from the B value for the Gauss, but the control and fibersol are not different, and the Gauss and fibersol are not different. That's what NS means. Those are not significantly different. Only the control and the Gauss are significantly different, where the P is less than, in this case, less than 0.01. Okay, so now I go back. So I've put the B values through my InStat program. InStat says the B values are different. Okay, some of them are different, some are not different. So here's what they are. Here's for the control, it was 19.48. For Gauss, it was 15. For fibersol, it was 1812. I'm sorry. So now what I need to do is I line up my averages, which are here, from left to right, small to large. So the Gauss, which is 15, goes here. The fibersol, which is 18.12, goes here. And the control, which is 19.48, goes here. Okay, so we've lined our averages up, small to large. All right. Here they are. Now, my InStat program tells me that the control and the Gauss are different, but the control and the fibersol are not different. Let's see if we can determine something from that. Control and fibersol are not different. So what I do is I draw a line under control value and the fibersol value, and I label that line A. Okay. Then if I go back to my statistics again, it tells me that the Gauss and the fibersol are not different. Okay, so I'll go back here. Gauss and fibersol are not different. So I draw another line under that, and I call that one B. All right, so notice that C is associated with A, Gauss is associated with B, but the fibersol has a line from the A and the B under it. So what we have to do now is transfer those A and B values to a table. Okay, so we can do that. Here's what they look like. Remember, the control was associated with A, Gauss was associated with B, but the fibersol was associated with both A and B. And again, here's the kind of things that you have to put underneath each table. Means in columns, and you're only comparing columns. You can't compare in rows because that's not the way we did the analysis. Means in columns not bearing the same letter are statistically significantly different, p less than 0.05. So that says that in here, the B value for the control and the B value for the reduced fat plus Gauss, they are statistically significantly different. However, the control B value and the fibersol B value are not, because there's an A here, there's an A here. All right. Here, none of these are different. And here, all of these are different because they each have their own little letter. Okay. Now we can take these statistical descriptors and go back to the graph that we made early on, and we can put those values in here. For the L values, we got an A, B, C. We have no letters here because none of these are different. And we have an A and a B and an AB. And so you can actually incorporate these statistical descriptors into both tables and into figures as well.